In this part, we dig deeper into the UI abstraction class. Moving on, we reach the fields of the class and the start of the UI. Let's step over those. First, we have the form delegate instance. This is only relevant if we are in a phone mode and not in the tablet mode where we have a different class in place. The container is the current UI. Since form is a subclass of container, this will work for both the form and the tablet UI mode. Elements such as the OK cancel buttons are added to a container, and then the main container is wrapped up to include these additional buttons. This allows us to keep the code mostly seamless. But we sometimes need access to the actual decorated container, for example when we need to replace it. Don't worry if you don't understand this, it will be clearer as I go through the actual code. This is essentially the equivalent of getCurrentForm, only in this case we get the current UI abstraction, which will work correctly. Let's move on to the creation code and specifically the code that occurs when working with a tablet. Notice that isTablet will return true for desktops as well, so there isn't as much of a need for isDesktop unless you need it to be truly distinctive from tablet. By default in codename 1, the content pane of a form is scrollable on the y-axis. So I tried to replace this behavior here, so the code will feel seamless. The UI abstraction client property allows us to get access to the UI abstraction class from the component. This is useful for methods that need access to navigation logic but run from the UI code. For instance, a button in the UI that triggers form navigation. The decorated container defaults to this container. Unless we have a \OK button pair, in which case we create a new wrapper of the container and use the decorated container for that. We just create OK and cancel buttons, which we add into the south of the container using a grid layout. Notice the usage of grid layout ensures both buttons will have exactly the same size, which contributes to nice aesthetics. If you recall the previous code for OK and cancel we had in the form delegate, this will seem almost identical. But then you might notice the current UI is really the UI abstraction class, and we use showBack from there and not from the form. This is the else statement that runs in case of regular forms or in phone mode. It just defers everything to the form delegate. Moving on, we can see the common methods for show are implemented normally as one would expect by calling show or showBack respectively. But there is something interesting here. Tablet UI, which we use to implement the show logic. Tablet UI is the equivalent for form delegate for tablets, but unlike that class, it's a single form that never changes. I'll go to that class soon. Other delegates work seamlessly with the container. Notice that add on a form will work well, and so will add on a container. So in this case, we can just seamlessly delegate. BindFab works exactly as we would expect for a form, but with the tablet we need to rewrap the decorated container and use that as the new decorated container. To understand why, you need to understand that Fab wraps the content of a container and adds a layered layout where it resides. If the parent is a form already, then we have a layered pane, and it just uses that. But if it's not, then we need to use the container that the fab returns, which is where the delegate container comes in really handy. Finally, all of these methods are just callbacks that we invoke in the code. The submit button validation is handled here, so it will work with the internal OK button without exposing a button component that might be fragile.